Absolute value functions. This is section 2.6 of our textbook. An absolute value function is defined by the absolute value of x equals x if x is greater than 0, 0 if x is equal to 0, and negative x, or the opposite of x, if x is less than 0. The graph of this piecewise function consists of two rays. The rays start here at the origin, so that's the beginning or the vertex of the rays, and it is V-shaped and opens up. As you can see right here. To the left, x equals 0, the line is y equals the opposite of x, or y equals negative x. On the right-hand side of x equals 0, the line is y equals x. Notice that this graph is symmetric in the y-axis. It's along the y-axis, it's symmetric right here, because every point xy has a corresponding opposite of x, or negative xy, on it as well. So 2, 2 has negative 2, 2, and so on. This particular formula you will be getting very, very, very used to this year. It is our vertex form of a function, and you'll want to copy this one down. Y equals A, absolute value of the quantity x minus h, plus k. And each of these values does something to our graph. Our vertex is found at the coordinate where the x coordinate is h and the y coordinate is k. So h is our x coordinate, k is our y coordinate. And the graph itself is symmetrical in the line where x is equal to h. The graph is V-shaped. If a, this value, the coefficient in front here, if a is less than 0, the graph opens down, or a is negative. Additionally, if a is greater than 0, the graph opens up, where a is positive. The graph is wider if a is less than 1, or the absolute value of a is less than 1, meaning that a is actually a fraction, because fractions are less than 1. And if the absolute value of a is greater than 1, the graph is narrower, or the slope is steeper. So it looks very thin when it's narrower. A is the slope to the right of the vertex, and on the left-hand side, the opposite of a is the slope. To graph our function, we first need to plot the vertex, and there's a lot of different ways to do this. We are working with traditional points for all of our parent functions, and we're talking about that in class. But in this particular instance, they're describing finding the vertex by setting the x minus h portion of this equal to 0, so you can solve for x and find out what the x coordinate is. The y coordinate is very obviously in the formula here, our k value. Okay, this would be our y coordinate. We set x minus h equal to 0, and that will give us what our x coordinate is. Once we have our vertex, it's very easy to plot the rest of it. We're going to use our slope, and our slope is found in the same place as always. That's our a value. This is the slope in this particular function. That will help us plot another point to the right of the vertex. And then what we'll use is our symmetry around the x equals h line to plot our third point and continue plotting 2 additional points. For most of these graphs, we are looking for 5 points if we can fit them all on the grid that you've been given. Then the graph is complete, and we do want to have arrows on the ends of our rays. So we're going to go through this particular one and graph it. We've got a couple different things to think of as we're looking at this. First off, this is an x plus 2 when our formula is x minus h, so our h is actually equal to a negative value since this is plus. Our a in front is negative, and remember that helps us figure out whether the graph is opening up or down. And we do have a k out here that is positive, so this tells us where the vertex is in the y coordinate. This is when we complete this action, we'll figure out the x coordinate from the inner part of our absolute value. So we have plotted our vertex, which is here at -2. If we set x plus 2 equal to 0, we get -2. You can also think of our vertex as hk, which is -2 and 3, and this is where our vertex is. The next step is to take our slope and plot the point that comes after that. So there's our vertex. We're applying the slope equals -1 to this point. So going to the point right here, we're going to go down and over 1. This will be our next point, down and over 1, just as if we were doing a line. Our line of symmetry is where x equals -2 as well. So it's right, let's do this. Right here is our line of symmetry where x equals -2. Come on, there we go. And you can see they did a really quick drawing of this, or the timing is going pretty quick. Our line of symmetry in the middle, right here, -2. We went from our vertex, down 1 over 1, down 1 over 1, down 1 over 1, as if we're climbing stairs. And on the other side, since this is our line of symmetry, we've got a point here, which means we'll have another point there, and another point here, and so forth. Here's our V shape. It's symmetrical. This is our vertex, and there you go. Now I'm going to have you stop or pause the video for a second and graph this particular absolute value function. All right, let's see how you did. First step is to find our vertex. And so our vertex is found if we take x minus 1 equaling 0, we get x, or the coordinate of our vertex, equals 1. If you think of x minus h as well, h is equal to 1, y is equal to 1, so our vertex is found at 1, 1. And we've got that plotted right here. Okay, the next thing to consider is we have a negative in front, so our a is a negative, and we know that our axis of symmetry is along the x equals 1 line right here. So this is our axis of symmetry right here. And as we're looking at that, we use our slope, down 1 and over 1, to graph our next point, and keep going until we have a nice setup on this line. Using the x equals 1 symmetry, we can then follow on the opposite side to create the V. We should have arrows on the end. So make sure that you're including that. Use as much of the graph as you can, but a minimum of 5 points is generally what we're looking for. Moving on, we're going to figure out how to take a graph and write the equation for the graph and put it in our vertex form. So looking at this particular graph, we want to figure out where our vertex is, which is right there. And we're going to take that information and write out our vertex, realizing that our vertex is HK, and we can plug those values into our formula, which is our vertex form. And here we go. We've got A, absolute value of x minus h plus k. And so our values here, when we're looking at it, our h is 0 as given. Our k is -3. So we replace those in there, and now we've got to figure out what our a is. And there's a few ways to do that. One, we could substitute a value in for the coordinate in order to solve for a, or you could simply look at our slope. If we go to our vertex, we find another good lattice point for our second point. We know that we've got a slope of up 2 over 1, so it's going to turn out really nicely that we have a slope of 2. And we did need to double check which direction our graph is opening in order to figure out whether a is a positive or a negative value. And this one is opening up, therefore it's positive. And our equation is y equals 2 absolute value of x minus 3. Your turn. If you would please pause the video and write the equation for this graph. All right, you should have first found where the vertex is. Vertex here at 0, 3. Other information that we've got from this graph is it opens up, and that means that our a will be positive. We can look at our slope. This lattice point to this one is up 1 and over 2, so we're expecting, since this is a fat graph, that our a is going to be less than 1. So let's see what we got on this. And our equation should be y equals 1/2 absolute value of x plus 3. All right, that's it for absolute value graphs. Why don't you go ahead and get out your study guide and complete the problems in the study guide. If you have questions, make sure you ask in class.